Okay, our first video today is on fossils, and I'm surrounded by some really cool fossils here, and we'll talk about those as we go. So first thing we've got to look at is really, what is a fossil? What is a fossil? And you might have an idea of what a fossil is, but really it's any evidence of life. And that's a pretty vague explanation, but it's sort of what a fossil is. See, a fossil can be anything. It can be an imprint, a cast, or a mold of any animal or any plant that's preserved in rock. And I'm surrounded here by evidence of life that is preserved in stone. So let's write that down. It's an imprint, a cast, or a mold of any animal or plant preserved in rock. Cool. We're going to, hopefully we will be looking at the different types of fossils, and we're going to be looking at how fossilization occurs. But I guess we probably want to look at some examples. With fossils, we can get original material, which has been preserved. We can also get replacement of material. So something might start off as bone, but it might be replaced by something else like iron pyrite, or even as something like a clear calcite there. But sometimes it can be something as simple as a stone tool, like this one here. We'll talk about that in a minute. So let's look at, firstly, the types of fossils that you can get. So what are the different types of fossils? All right, so we're going to start off with unaltered, because these are pretty cool. Unaltered. So, anything that's unaltered, you can probably guess, is the original material. It is any original material. And when I say material, I mean bodies, or even tools, prints, or tools, but it's got to be preserved. That is preserved. So let's look at a couple of ways we can get unaltered. And firstly, we're going to talk about good old mummification. And I know you're all immediately thinking of of Egypt and mummies. And yeah, it's dried preservation. E.g., shall we put Egyptian? I'll put mummies. So one of the reasons that that the Egyptian sarcophagi and the bodies of the dead in Egypt last so long is because of Egypt's climate. Egypt is, and always has been for a very, very long time, a dry climate. And because it's so dry, because we lack water, water is an agent for decay. So when we think about preserving things, sometimes you think about preserving it in a certain material, and we'll talk about that in a minute. But if we dry preserve foods, we obviously remove all of the water. And if body material is left in, for example, a dry sand or a warm, dry conditions, it's going to be perfect for that material, for all of the water to leave that material and the original material to be left behind. Which is why a lot of those fossils, a lot of those mummies, I guess, still have some of those features that we can sort of see, that soft tissue material that remains behind. So mummification, dried preservation. So next time you have some dried banana or dried apple, it's really mummified apple, and maybe you should call it that. Let's go to, and I'll do this one in blue, refrigeration. I've chosen the right color. So refrigeration is when material is trapped inside of ice. Material is trapped inside ice. And that prevents any decay. This is quite common, and it's something that we see quite a lot of. And because of climate change, it's something we're seeing a lot more as well. If you think about Siberia, if you go onto eBay, you'll probably see them. They're selling woolly mammoth fur and sometimes woolly mammoth tusks or even baby woolly mammoths, because what's happened is these animals have died 20, 30,000 years ago, and they've died and they've fallen into the dirt, which has been covered up and then turned into permafrost. Woolly, I'm not sure how you spell woolly mammoths or bears, and they're frozen, but due to climate change, the permafrost is melting, which means a lot of these guys are getting exposed, and we're starting to have more and more finds of woolly mammoths, and particularly these large bears in Siberia, and of course they're getting sold off. So this is an example of refrigeration. These are animals that are 20 to 30,000 years old, but they still remain intact, and all the tissue remains intact because it's been refrigerated. There's also been talk about bringing woolly mammoths back to life. I guess you could say it's possible because that refrigeration has held together all that cellular material. So DNA is possible to collect. It doesn't just link to animals though, it also happens to people. And there's some really good examples of people that have been frozen. One is a guy called, I don't know if it's his real name, his name's Oti, and he's called Oti the Iceman. And he was found in the Italian / Austrian Alps about 20 years ago. And he was from 3,300 BC. So 5,500 years old, almost 5,500 years old, frozen in the Alps. It's actually quite a cool story because he was murdered and there were arrows in his back. He was covered in tattoos, and all of this was evident because he was literally preserved. So refrigeration is another way of getting those unaltered materials, the original materials. Okay, let's keep going and let's look at other ways to preserve bodies, and let's go to green because this will suit this one well. And this is called Bog Preservation. So this comes down to things called peat bogs. And peat bogs are, I guess you could say, they're spongy They're fields or they're wetlands areas. They're like a wetlands of spongy moss, and they form these big thick layers of this really, really ancient moss. But what's also interesting about these peat bogs is they are anoxic. Which means they don't have any organic material. So not organic, but they don't have any oxygen. So organic material doesn't decay very fast. And what it means is people that were, well, actually, most of the people they've found in the bogs have been murdered or ritualistically killed. But some of them are really, really old. The oldest one is a guy called Karl Bergman. He's found in Denmark, and he was about 8,000 years old. And these guys, it's really interesting. They've been able to see everything about these guys, what they look like. All of their clothes were preserved. Even the contents of their stomach was preserved as well. They were able to find out there was one guy, this bog man in Ireland, and they were able to see that he had porridge for breakfast on the day he died because of what was in his stomach. But what was really interesting is the evidence from that gave scientists an understanding of what type of barley and what type of oats were growing 3,000 years BC. And these fossils, these living, these unaltered fossils really give scientists a much better insight into past environments than replaced. I'll keep writing a little bit about bogs. So material doesn't decay fast. Example, e.g., 8,000 years old, and he's called Karl Bergman, and he's in Denmark. Now, that's people or woolly mammoths, and that's pretty interesting. There's another one here, and I've got it right here, and this is an example of what you'll see pretty much every time you go to the beach. This is a piece of limestone from here in WA, and it's actually not limestone. It's a rock called Calcaronite, or it looks like calcaronite. And you'll notice that inside there's lots of shells, and there's even this little shell here that looks quite purple. These are the original shells. They've not been replaced. So what's happened here is this rock has formed, and it is rock now, but it's collected these shells on the way. They've stuck to it, and if this rock, which is about 100 to 120,000 years old, if this rock was to be preserved or even lithified further, this material would probably be altered. But saying that, in this case, it's 120,000 years old is old enough to call something a fossil. So we'll write down here about this. Hopefully I can get this in there. Shells. So hard, shelly material can remain unaltered if it is similar material to the rock it is found in. So this material here it's a sandy, it's partially calcareous material, so limestoney material, and but with further lithification, these would be replaced into something else. There's one other example here, and it's these guys. And you might look at this and you think, oh, that looks a bit sort of familiar. That looks a little bit like somebody could have used that for cutting. And this here looks almost like it was sort of made to be that shape. And if you look at the little scallops here, you can see it was made on purpose like this. These are Stone Age. Actually, I should say not Stone Age. What am I saying? These are Bronze Age knives and arrowheads. There's a bit of a story about how I found these. I used to live, when I lived in the UK, I lived near this big hill called Sharpenhoe Clappers, and it was quite an interesting place, and I went up there for a bit of a look one day, and while I was walking around, these were just sitting on top of the ground. Actually, there was a little bit of a pile with a few of these in, and what I'd stumbled across was a little place where they made these. You would have people that would just be churning these little knives out, or these arrowheads out all day. They're about 2,500 years old, so they are old enough to be fossils. It's the original material, because this was, it's not changed into anything else. So they're fossils as well. So another type of unaltered fossil we can have is tools. I'll write down here, and I'll put a little, so get that whale tusk out of the way. Tools can also be called fossils. I'll put those guys there. Okay, so our next video will be about altered and how fossils are actually formed. So this is unaltered fossils, and it's part 1. Talk to you soon. Just one little note on fossils, on unaltered fossils, and that is entombments. And something we didn't talk about earlier, but and this refers just to one thing, and that is amber. So if you guys seen Jurassic Park, you'll know that they magically get the DNA from dinosaurs out of a mosquito that's trapped in amber. Well, that bit's fictional, but animals and insects have been trapped in amber for millions and millions of years, and those organisms are perfectly preserved in their original material. And theoretically, the idea is correct that the DNA of the insect or the animal, if there's living tissue there, could be preserved. However, if it was a mosquito, I'm afraid the DNA from the dinosaur, there's not enough of it. But entombments, amber and insects, it's very much a real fossil. Okay, let's continue with our fossil story, and let's look at altered fossils. And these are fossils that have been changed. These are altered. So there's a couple of different types of alteration that these fossils can go through. Let's go with the first one, and that is replacement. So replacement is simply the tissue or the bone is replaced. Sorry, Emma, let's get out of the way. With another mineral. Now, I've got a couple of examples to show you here. That is these guys. So I've got a little selection of Ammonites. These Ammonites all come from the same place, a place called the Jurassic Coast on the south coast of WA, of the south coast of the United Kingdom, near a place called Lyme Regis. If you ever look at it, if you ever get a chance to go there, you have to go there. These guys, I found all these on the beach, and the Ammonites there are approximately. So these are from the Jurassic Coast. They're about 180 to 185 million years old, and they sort of border the Jurassic and Cretaceous periods. and they're really good examples of replacement. So these first two here in the middle, these are two different species of Ammonites. I'm not sure their species names, but these two have been replaced with pyrite, iron pyrite. Yep, fool's gold has grown into these ammonite casings, and what's happened is the ammonite has died, been buried in sediment, and then the original shell material has gone away, and it's been replaced with iron pyrite crystals, which have grown in those spaces. Here we've got another one, and it's another ammonite. It's a bit smaller, and I'll probably show you there. You can see it there. And it's very light in colour. So this is a calcite. And calcite is quite common in limestones, which is what this rock is. And the ammonite's been removed and been replaced by calcite. Here is one that's been replaced by quartz. It's very similar, but silica has got in and replaced those that ammonite that's there. So we end up with the original. It is very much what it looks like, and it's very detailed in what you see, and you actually see a lot of the finer features, particularly, I don't know if you can even see on this ammonite, there's some little shell markings that would have been on the outside of the shell. So this is replacement. And let's write a little bit more about that. Replaced by another mineral. Normally it's a soluble mineral. Calcite. Quartz. Or iron pyrite. There have been some amazing, if you ever get to go to Coober Pedy, Coober Pedy has opal fossils. So you get belemnites, which are the little bit like that actually. You can get ammonites or shells, and they are as opals. They're extremely valuable, but they're beautiful. Let's look at the next type, and our next type of alteration is permineralization. So a lot of these are quite similar. Here, the pore spaces are filled or replaced. Oops. By other minerals. And it's very similar, very similar to replacement. Sometimes this permineralization occurs really slowly, and you only see partial mineralization of a fossil. I don't have any samples of that to show you, I'm afraid. Let's go to the next one. Let's do this in red. And this one's called carbonization. Okay, so carbonization is the conversion of dead matter into carbon. So it's very different from that replacement or permineralization, in that the actual material is converted to carbon, and it normally happens in organic fossils that are very thin, and they produce a very thin, fine layer of carbon. It's not turned into coal, I've got to say. That's a much slower process. This is called destructive distillation. Destructive distillation, and it's when, it's just literally when organic material is converted to carbon. I'll write down a little bit more about this though. Often and it occurs mostly in terrestrial fossils, so mudstones. very, very common. Or fine, very fine grained fossils is when you'll see those. Just looking at some of the fossils we've got around us here, we've got a couple of bivalves here, these small shells. These just are good examples of replacement. That replacement, though, often replaced that replacement really does, it shows a lot of the features that was originally there on the original rocks or the original the organic material. Let's just talk a little bit about molds and casts and what they are. So, molds and casts. I find a lot of students get confused with these. And to help, I've got something, a little thing that I don't know, a little thing that I bought while I was in Paris, and it's this little cast and a mold of a horse. And if I was to take this out gently, it looks like it's broken. I filled it with wax and made the horse. There's his legs. Didn't work out too well. But you can see that this is the mold and this is the cast. Okay, the mold is a perfect reproduction of the inside of something, and then the cast is that duplicate of the original. An example of this is this little shell here. So this would have looked like any sort of I don't even know what you call these shells, but one of the little shells that you might get a little hermit crab living in. But this is the cast of inside of one of those shells. Another example of a mold is here we have this part of I think it's an ammonite. It definitely doesn't look like a shell to me, but this is the inside, so this shows the outside. So this would be a mold, and this here would be the cast. Okay, if I leave it like that. So how do we write that? Well, let's write that down. I'll put these over here. Oops, horse has lost his legs. So a mold is an imprint from something buried and removed. The cast is the duplicate of the original organism. So sediment, or often what it is it's soluble material like calcite or silicon. Fills the mold. And there you have it. Oh, by the way, if you're wondering what this is, it's a whale tusk. And I'm not sure of the age. Okay, let me move these out of the way so you can see the rest of the notes. Let me get this horse back together. There you have it, altered fossils.